Hello, this is Tamaskan. Today we're going to see some concepts related to mechanics. It's not that much detail, but we'll try to cover some of the concepts related to this thing, which is going to be as an introduction. So I want you to stay with me, and I hope this lesson is going to be more interesting. So let's start from defining the fluid. So a fluid or liquid is capable of flowing, right? It can flow. It has no own shape, but conforms to the shape of the containing vessels. Right? It has no own shape, but it fits wherever it goes. So a fluid is a substance that continuously deforms under applied shear stress. When you apply shear stress, it can easily deform, which is we call it fluid. Liquids are like water, milk, air, or steam. And matter exists in two states, right? The first one is solids and the fluids, and also fluid state being commonly divided into liquid and gaseous status. So we will this is just an introduction. Have this in your mind, which is fluid. It has no own shape and it conforms the shape of the containing vessel, and also it can deform under applied shear stress. Let's see the difference between solids and fluids. A solid is a generally own shape and change in volume under pure compressive load. It's resistant to change in shape without a change in volume under the application of tangential force. The other thing is the spacing and latitude of motion of molecules are very small in solids, but they are very large in liquid and extremely large in gas, which is like the motion of the molecule. Especially, let's say, if there is a solid, if this one is a liquid, if this one is a gas, like the motion of molecules is very what we call the spacing and the latitude of the motion of the molecules here is very high or very large in the gas than in the liquid, and liquid is also larger than in the solid. The other thing is the intermolecular bonds are very strong in solid. The intermolecular bond is very strong in solid because the atoms are like highly densely attached. So we can say the intermolecular bonds are very strong in solids and weak in liquids and very weak in gas. Solids are very compact and rigid. Solid materials we can take steel, wood, and plastic. So let's see some point here. Gas, solid, and liquid. We have gas, we have solid, and we have liquid. So this in terms of phase, we have solid, liquid, and gas. So in terms of spacing, in solid it's close. In liquid close, but in gas they are far apart. As you can see, the molecules are far apart in gases. In terms of energy, in solid there is low energy, in liquid moderate, in gas there is high energy. In terms of motion, in solid it's going to be vibrational, in liquid rotational, and gas translational. Volume is for solid and for liquids is definite, but for gas is indefinite. In terms of shape, solid have definite shape, but liquid and gas have indefinite shape. So this is like the overall difference of this gas, solid, and liquid, the three states, considering the spacing, the energy, the motion, the volume, and the shape. And also we can say, like in solid we have rigid, fixed shape, and fixed volume. If it is a solid, there is rigid, fixed shape, and fixed volume. And also it cannot be squashed. But in liquid we have not rigid, no fixed shape, but still there is fixed volume. So this also cannot be squashed. And also in gas we have not rigid, not fixed shape, no fixed volume. this thing can be squashed. So this one is also an interesting concept. Like you can have a good understanding of these three status: solid, liquid, and gas. So the solid and the liquid, this is a fixed volume, but in gas there is no fixed volume. But in solid there is fixed shape. In liquid and in gas there is no fixed shape. And also solid is rigid, but liquid and gas they are not rigid.